We're on workbook page 156, number 11. Tracy checks the digital tablets made at a factory. In one of the tablets, she finds 1/12 have a cracked screen. In the same box, she finds that another fifth have the wrong software. What fraction of the tablets in the box either have a cracked screen or the wrong software? We're going to put all of this together. Excuse me, I have a denominator up there of 20. This one is fifths. So if we take the numerator and denominator here times 4, we will end up with 20ths. So we have 1/20 plus 4/20. Your fractions will look so much better than mine. This ends up equaling 5/20. And you can see that they're both divisible by 5, so divide that by 5. You end up with 4. Divide your numerator by 5, and you end up with 1. So 1/4 of everything has either the wrong software or cracked screens. That's a bummer. Number 12, on Tuesday, the dance team spends 1/8 of the practice time trying on uniforms and 1/6 of the time choosing music. They spend the remaining time dancing. What fractions of practice time do they spend dancing? Alrighty, so again, find your common denominator. Let's use 24. Take your 6 times 4, take your 1 times 4. And then the denominator here, 8, take it times 3. Do the same thing with your numerator to keep it proportional. We've got 3/24. I would like to do this vertically up and down, but it's just a little trickier when I'm not writing at the board. So 3/24 plus 4/24, and 24 stays the same. 3 plus 4, you've got 7 chunks of the 24. We have 7/24 is how much time they spend doing uniform try-ons and then choosing the music, and we're wondering how much time they spend dancing. So the full time would be 24 out of 24. Take away the 7/24, and what we have left, that difference, is their dance time. So we end up with 17/24. Explain how we found our answer. Well, we added try-on time and music selection time and subtracted that from one whole. All right, 13 through 16. I would encourage you to pause this, do your best on 13 through 16, because this is a review. You know how to do these, okay? And then play the video and check your answer. Here we have fifths and tenths. Double the fifths to make them into tenths. Take your numerator times 2 as well. And you have what ends up being 4/10 minus the 1/10 stays the same. And the answer for this one is 3/10. Nothing to simplify. So that one just is what it is. 3/4 minus 1/8. 4 times 2 gets you to 8. 3 times 2. We have 6/8 minus, make sure you double check whether you're adding or subtracting. Take away 1/8, and we end up with 5/8. 5 is not even. 8 doesn't end with a 5 or 0, right? So that's it. It's just 5/8 there. 1/3 plus 5/12. Well, 3 times 4 gets me to 12. I really appreciate when we just convert one of the fractions, one of those denominators instead of both. It's really, really handy. Just to switch. Okay, so times 4 times 4. Here we've got 4/12 plus 5/12. You know the drill. The denominator stays the same. Add your numerator. We have 9/12. Be careful here. 9 you can divide by 3. I'm going to put the slash. Divide by 3 for the 12. 9 divided by 3 is 3. And you have it over 12 divided by 3, which is 4. So number 15, your simplified answer is 3/4. Okay, number 16, we have 16ths and fourths. Let's change those fourths into 16ths. If you split 4 into 4, fourths into 4, that's exactly what I did for Pi Day. I cut the pizza in half, or the pies in half, swiveled them, cut them in half again, made fourths, and then I cut each fourth into 4 pieces. So we had little 16th slivers to sample. Anyway, we've got 1/16 plus 12/16, put it all together, and we get 13/16. Let's see, 13 is prime. We can't simplify that anymore. 16 you can divide by 8, 2, or 4, but not the 13, so that's it. Number 17, Malcolm completes a 5th of his new video game. After 1 week, he completes another 10th of the game. After 2 weeks, he completes another half. How much of the game does he complete? Model the expression, find the sum. Okay, so model with the expression, you're going to put 1/5 plus 1/10 plus 1/2 together. Okay, and then make them all into tenths. So take numerator and denominator here times 2, numerator and denominator here times 5. So we end up with 2/10 plus 1/10 plus 5/10. And just double check, that's the same as a 5th, 1/10, 1/2. We get 5, 6, 7, 8/10. Simplify it, divide 8 by 2, you get 4. Divide 10 by 2, you get 5. So 4/5, and I want to say the label is of the game. So he's done most of the game. Good work, Malcolm. Alrighty. Assessing reasonableness of mixed number sums and differences. Page 157. Caroline trains every weekend for a track and field competition. She writes down how long she spends running sprints and jumping hurdles. How many hours does she spend training on Sunday? So we have 2 2/5 of an hour for sprints and 1 1/4 hour for hurdles. The very first thing, write an expression to model. So okay, I'm going to do my best here. It is not easy on the computer. 2 2/5 plus 1 1/4. Excuse me. And okay, and they just want the expression there. So that's literally all we're doing. 2 2/5 plus 1 1/4. Then estimate the answer. Well, 2 2/5, 2.5 is half of 5. So 2/5 is really close to that half. So I'm going to put 2 1/2 plus what is essentially just 1 whole, right? Because that quarter is closest to 1 whole. So 2.5 plus 1 whole equals, you have 3 whole and then 1/2 there. Okay, letter C, rewrite the expression in part A using equivalent fractions with a common denominator and find the actual sum. Alrighty, I have to double check. We have 5th and we have 4th, so let's use 20ths. So 2 2/5. I'm so sorry, this looks wonky. We're just doing our best here. Oofda. 2 2/5 plus 1 1/4, I believe. Okay. Switch the colors. So take this times 4, take the numerator times 4, take the denominator here times 5, and the numerator here times 5. Oh boy, it's time for me to call you. Can I write this really quick and pause the video? So we've got 2 8/20 plus, you guys probably already have this solved. It's so slow for me when I'm typing. Plus 1 5/20 equals, you have 3 whole out in front. 8 plus 5 gives us 13, and it's still out of 20. So 3 and 13/20ths. Okay, how many hours does Caroline spend training on Sunday? Repeat. 3, whoopsie, 3 and 13. Maybe I'll just try this. It's been a while. It's been a while since I've tried this. 3 and 13/20ths of an hour. So roughly 3.5 hours, right? Is your answer reasonable? Yes, because, yes, 3.5 is close to, I'm going to put the squiggly equal sign there, 3 and 13/20ths, because half of 20 would be 10. So it's actually a little more than 3.5. So that's just our quick explanation there. Workbook page 158, number 2, step it out. Jonah's best pole vault jump is 7.25 feet. A sign in the gymnasium shows the gym's record. How much shorter than the gym's record is Jonah's best jump? Write an expression to model. So you're going to go with the bigger number, or in this case, the big record, right? 8, I'll try to make this tidier for you. 8 and 7/12 of a foot. And then you're going to take away whatever he jumped, 7 1/4, 7 1/4 of a foot. You know that this is like the golden rule of virtual learning. Your stuff will be so much neater than mine. And that should be not on the line. Okay, so 8 1/12 minus 7 1/4. Estimate the answer. Well, 8 and 7/12 is quite close to 8.5, because half would be 6 out of 12, right? See how important knowing your math facts is and all these multiples and everything. So it's roughly 8.5, and we're taking away just basically 7, right? So 1/4 is right between 0 and half, but we'll just kind of knock it down there to a 7. Estimate the answer. Okay, and they do want us to actually like do the estimate here as well. I was just double checking because you know how they have us like repeat things and I get ahead of it sometimes. So when I subtract fractions, I like to start at my smaller one, kind of like counting back change in a store. You maybe haven't even experienced that in your life, but it happens. So start at the lower one, 7, and count upward to your bigger number. So 7 plus 1 whole gives you the 8, plus another half gives you that half. So 1.5 is our estimate. Letter C, rewrite the expression in part A using equivalent fractions with a common denominator. Okay, so we've got 8 and 7/12 and 7 1/4. Okay. Kind of wish I could just copy and paste that, but we'll go with it. 8 and 7/12, and then we're taking away 7 and 1/4. Okay, so I'm going to leave the 12 alone. Let's change that 4 into a 12, take it times 3, take the numerator times 3. So we have 8 and 7/12 minus 7 and 3/12. Okay. You always want to check your fraction first, because sometimes it doesn't work and we have to actually borrow from our whole number, and that gets really fun. Of course, slightly complicated, but also really fun. Okay, so 7/12 minus 3/12, you know how to subtract your fractions. That's 4/12. Okay, and then 8 minus 7 is 1. Okay, 4 out of, let's see, do we answer it? How far? Okay, yeah, so whoopsie, write an expression. Sorry guys, I did it again. I got ahead of myself. So write an expression, boom. This is all they want right there. 8 and 7/12. That looks much better than this, right? Minus 7 1/4 with the common denominator. Sorry, I'm off again. I just had to rewrite it to show you how we get the common denominator. This is what you need to write. on that line for sure. So that's what they're going for here. Then they're asking how far is the jump from the record? Well, he's 1 4/12 of a foot away, which I'm going to use the slash here because I don't have a beautiful division key. They should make those for math teachers. I would love that. So you have 1 whole and then 4/12. 4 divided by 4 is 1. 12 divided by 4 is 3. So it's 1 1/3. I want to say it's feet. I hope. Yep. So 1 1/3 of a foot. Is our estimate reasonable? Yes, because 1/3 is close to 1/2. 1 1/3 is close to 1/2. Let me see here. Let's make a shape. So just want to show you really quick. Obviously, you know what a half looks like. So I'll just actually kind of skip that one. And if you color in 1/3 here, I'm gonna get a bigger thing. Okay, you color in 1/3. It's really close to 1/2. So straight up and down here is your half mark, and it's just a little ways off of that. So it was a very good estimate. Okay, number 1, Jenna competes in the high jump. Her best jump in the first meet is 4 1/4 feet. Her best jump in the second is 4 5/6 feet. Write an expression using equivalent fractions. Okay, we have to pay attention to this. Using equivalent fractions with a common denominator, because some of you are not doing that in your assignments, and you need to do that when they explicitly tell us to. Okay, so it can be really boring to read the whole thing, but it is important. Okay, if you just glance and do something with your numbers, you don't really necessarily know what they're asking. Okay. Model how much of the height her jump increases. By how much does the height of her jump increase? Show that your answer is reasonable. So start with that bigger, let's see. Actually, first, let's make these the same denominator. So we've got a 6 and a 4. Let's make them into 12. Some of you might look at that and say, hey, let's change them to 24. And that's fine. Just know that you're going to have more simplifying and reducing to do later. So just be really careful there. Okay. So rewriting these here, we've got 4 3/12. And we've got 4 10/12. Okay. So clearly, when we're checking this, 4 10/12 is the bigger fraction. So I'm just going to scoot this one back here. Okay, by how much does the jump increase? Well, to figure out the difference, we need to subtract these. And we have 10/12 minus 3/12. 10 minus 3 is 7. It's still out of 12. 4 minus 4 is nothing. So 7/12 of a foot. That's the increase. Show that your answer is reasonable. Well, if we do a quick check here, 4 5/6 is close to 5. Take away 4 1/2, or excuse me, 4 1/4, which is basically 4. And our answer should be about 1. And 7/12 is actually a little bit closer to half than 1 whole, but it's between half and 1 whole, right? So quick check with some benchmarks there. Our answer is reasonable. Last part of the page, write the expression using equivalent fractions with a common denominator, then find the sum or difference. So we're not estimating here, we're just straight up solving them, okay? Rewrite, so I'm going to do my 5 times 2 to make the denominator a 10. You have to keep this all proportional. So here you have 2 6/10. And we're adding, okay, be careful because some of you just decide to add or subtract based on whatever you want to do, and that's not necessarily what they're asking. So just be really careful. 2 6/10 plus 1 3/10. Sometimes if you get an improper fraction in your mixed number answer, you have to shift it so it looks as beautiful and proper as possible. Okay. So whole numbers here, 2 plus 1 is 3. 6 plus 3 is 9, and it's tenths. So 3 9/10, that's your answer. You can do a quick check if you want. 2 3/5. You could bump it up to 3 plus another 1. Your answer should be about 4, and it is. So good work. Here we have eighths. There we have halves. I'm going to take my halves times 4 to make them into eighths. So here are 3 7/8. Stays the same. minus 1 4/8, and you know 4 pieces of pie out of 8 would be half of the pie, and who does not want that, right? Equals, okay, 7 minus 4, we've got 3/8. It seems silly that I'm starting with my fraction, but again, sometimes you start with your whole numbers and you have to change it. So just kind of a habit to get into. But 3 minus 1 is 2. So for now, you can actually do your whole number and then do your fraction subtracting. But again, if you have to do some borrowing, which is a little different than our normal borrowing, it gets just kind of, I don't know. I think it's fun because it's dorky and fussy and all the things that I am, right? But anyway, just a heads up there. It's not always as simple as doing whole number, and then fractions, but for now it is. So 2 3/8. That's our difference there. Okay. Way to go, guys. See you later.